This tutorial is tips on how to solve equilibrium problems. So first we need to know what equilibrium means. And if we look at the root of the word, equal, it means for equilibrium that all the forces equal each other out. They cancel each other out. So in this case, all of the up components of the forces balance out the down, and all the forces to the left balance out the forces that are acting to the right. If they are all balanced according to the first law of motion, it says that an object at rest stays at rest, or an object moving at a constant velocity will continue moving at a constant velocity if there are no net external forces. In other words, if all the forces balance, the object will continue doing what it's doing. It will not accelerate. So if you see that the object is either at rest or it says that it's moving at a constant velocity, those are the key things to look for, that we know that this is an equilibrium problem. So how do we go about solving equilibrium problems? Well, first thing we're going to do is draw a free body diagram. When drawing a free body diagram, you always want to draw the gravitational force, because we'll always be on the earth, and so that force is down. Then we want to look to see if there is a surface. If there is a surface, then there's a possibility of two forces. There's a possibility of the normal force, which would be acting perpendicular to the surface, and there's a possibility of friction, which is parallel to the surface. Now we have two different choices of friction. There's either static or kinetic. It is static friction if the object is not moving relative to the surface. It is kinetic friction if the object is sliding on the surface. And so you want to determine which type it is, and the direction of the force is not just parallel to the surface, but opposite. The direction is either being pushed or it is being moved. The next type of force is if there's a string, rope, or cable, there is a tension force, and that is directed along the direction of the string. And strings, of course, can only pull. You can't push with a string. The last type of force that would be given to you, so if they say about you are pushing a cart at 300 newtons, that would be considered an applied force. So those types of forces would be told to you. After we write or draw our free body diagram, we'll write down our givens, same as before. And at that point, we really proceed as we did in the past. We write down our givens, we write down what we are looking for, and then we go to our equations. Now really, we only have two options. Either we are in equilibrium, meaning that the forces balance out, meaning we're moving at a constant velocity or we're not moving at all, or we are not in equilibrium, which means we are accelerating. Now if we are in equilibrium, then the equations we go to are the total horizontal forces are 0 and the total vertical forces are 0, and we proceed from there. That's what we're looking at first. Later on, we're going to look at what happens if the forces are not equal to each other. In other words, what happens if the object is accelerating? Well, then we go to the second law of motion, which says that the total force is mass times the acceleration. So depending if we're in equilibrium or not, we go to two different routes here. We're going to start with equilibrium, then we're going to move on to when there is a net force.